image produced by convex mirror. This is convex mirror and this is principal axis. Principal axis. This is a pole of the convex mirror. So the center focus will be here and the center of curvature will be here. So you call it focus and center of curvature. When object is kept at infinity and rays are coming from the object parallel to the principal axis. When it is falling parallel to the principal axis, this is principal, rays are coming parallel to the principal axis. In a convex mirror, when rays are coming from infinity, the object is kept at infinity, rays are coming from infinity, the rays are parallel to the principal axis, right, parallel to the principal axis. So, when rays are parallel to the principal axis, it will pass through the focus in case of concave mirror, and otherwise it will appear to pass through the focus in case of convex mirror. For concave mirror, it will appear through the focus. Now we see it will appear. So it will go like this. This will go like this. And this will come and this will go like this. It will retrace it pass because it is passing through center of curvature. So this will pass like this. This will pass. So when the rays, parallel rays all are parallel to the principal axis, we can see paraxially when it is passing after refraction, it will go according to the laws of refraction. The center is from the normal at this point of incident is from a line drawn from center of curvature up to this point, that is normal according to the law of refraction. This will be the normal. So this is I, this is R. So the rays will reflect like this. So the rays will go like this. And this is the viewing area. So it means when images are appears to come from a point and diverges out. So the diverges out, these are the diverging rays. So it means the diverging image always will form a virtual image. So this much area, our eyes can see this much area. So the reflected ray, this is 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 the reflected ray. Reflected ray appear to come from the focus of the convex mirror. So what will be the case? Image is virtual. It will be erect. Image will be virtual, erect and diminished. This is case 1. Case 2. When the convex mirror is like this. Convex mirror, this is the pole, this is focus, this is center of curvature. In this case, the rays are parallel to principal axis. Case 2. In case 2, the rays are oblique, falling at oblique. So we can say the object is kept at infinity here. When we can take 2 rays, as already we discussed, 2 rays are enough to trace the image. So from the object is kept at infinity, 1 ray is coming and incident at the pole of the mirror. and after from the pole, after this will be the center of curvature. This will be center of curvature. Through the center of curvature, this is the normal, because normal is always considered from center of curvature from the point up to the point of incidence. So according to the law of reflection, it will get reflected like this. This is incident ray from the object kept at infinity. This is according to law of reflection. This is angle of incidence, angle of reflection. Angle of incidence is equal to angle of reflection. Okay, I will take another ray, parallel ray, but not parallel to the principal focus. It comes like this. When you see, already told, when a parallel ray is likely to pass through the center of curvature, it will retrace its path. It will retrace its path because this is the normal, this is the angle normal, this is the incident ray. Angle between the incident ray and the incident ray and the normal is equal to 0. Therefore, I is equal to R. Therefore, reflected ray will also have the same angle as the incident ray. Now, there is no way one ray is going this way, reflected ray is going this way, another reflected ray is going this way. There is no way both the point can intersect or appear to intersect. It can intersect in front of the mirror, in front of this convex mirror. So what we will do, we will extend this ray backwards. We will extend this backward, and at this point, both the rays seems to, this ray is coming this way, this ray is coming this way, and this seems to. So this is the image formed when the rays are falling at oblique in an oblique way. So when case 2, when rays are not parallel to the principal axis, the rays appears to come from a point. So when we produced it backward, the image is formed at the point of intersection of the reflected rays. One reflected ray this way, one reflected ray this way. When the reflected ray is produced backward, this reflected ray is produced backward. They seems to intersect at this point. At this point, the image is formed. The image is formed. Here is the focal length. The image is virtual. Why it is virtual? Because when we extend the reflected backward, they appear to intersect at point. It means always the converging rays, the image formed by the converging rays is always virtual. Virtual, erect, formed behind the mirror, and smaller inside. The image is formed, and the image is formed between, between focus and the pole. So in case of convex mirror, when the two rays, when rays are coming from infinity parallel to the principal axis, not parallel to the principal axis, here we have wide range of view area. In case of when the rays are parallel to the principal axis, when the rays are not parallel to the principal axis, they form the image behind the mirror of the convex mirror, and the image is virtual, erect, and formed between focal length and focal focus and the pole of the mirror. When the object is kept at infinity, we have seen where the image is formed. Now, when the object is kept at finite distance in front of the convex mirror, the image formed will be virtual and erect, and it will be formed behind the convex mirror. we will see how the image is formed using the ray diagram. This is the convex mirror. Convex mirror, how to identify? The bulged portion will be reflecting surface, the depressed portion is always polished. This is the pole and this is the principal axis passing through the pole. This is pole, and we keep the object anywhere between the pole and up to certain finite distance. Say we keep the object here. This is object, say A, B. When the object is kept here, we need two rays from the object to find out the image formed by this object by the convex mirror. So we take a ray which is parallel to the principal axis. This is principal axis. We take principal axis and we'll take one more ray which is passing through the pole of the convex mirror, that is coming from the object. So this is the focus. This is the focus, this is the center of curvature. Thus from the center of curvature up to the point of incidence, we draw the normal. So this is the normal. With respect to normal, this will reflect like this according to law of reflection. This is angle of incidence, normal. This angle is angle of incidence, normal, and reflected is according to the law of reflection. Now, a ray which is parallel to the principal axis, it will appear to pass through the focus. Okay, now it is a diagram is approximate. And another ray which is from the object passing at the incident at the pole. So it will get reflected according to the law, this law of reflection, because this will get reflected. This is the normal from center of curvature, point of incidence is normal, angle of incidence, this is angle of incidence for this ray, this is angle of reflection for this ray, and it will go. So this one reflected ray from the object, another reflected ray from the object, both are going like this, a diverging nature. It means where the image is formed by producing it backward. The image will be formed, because then there is no way the image, both the rays will intersect in front of the convex mirror. So by producing backward, images will be formed, appear to diverge from you. This is the image. This point is A dash, this point is B dash, this is focal, this is center of curvature, this is pole. It means, already we have discussed in the previous section, if from image is always formed by the intersecting ray. Here there is no intersecting, so we produce it backward. And the another characteristics, when rays are parallel to the principal axis, it appears to pass through the, when we extend it backward, it appears as if it passed through the focus. So this is where the image is formed. It is a erect image. The image will be like this. This is object B, A, this is mirror here, B dash, A dash. So we can see how in say case 2, when object is kept at finite distance, not infinite, because already we have seen the case of infinity already. We have seen the case of infinity. Now at finite distance in front of convex mirror. In front of convex mirror, when it is kept in front of convex, the ray will be, the image is formed at this point. The image, how the image is formed? Image is formed behind the mirror. What is the nature of mirror? The image is virtual, because there is no point of intersection of reflecting rays. It appears This both the rays are, one ray is going this way, one ray is going this way. When extended backward, both these rays, it appears to intersect at this point. When it appears to intersect at a point, it is a virtual image, and it is, nature is erect because this is also above the principal axis, it goes above, so image is erect, ERE, erect, diminished. And what are the other formed behind the mirror? It is diminished and smaller in size than the object. Any other quality, virtual image, erective, and it is formed in front of the mirror. So the image is formed in front or so behind the mirror, behind the mirror. Image is found behind the mirror, and where it is formed? Formed between focus, this focus and the pole. Focus and the pole. Uses of convex and concave mirror. Uses of concave and convex mirrors. Concave mirror. This is concave mirror. Rays coming parallel to the principal axis actually gets converged at a point. At a point that we call it as focus. So this is, we can call all the rays are converging. So it is also called converging mirror. This is concave mirror. Then convex mirror. Convex mirror. Ray is coming, it will go like this. Ray is coming this way, parallel to the principal axis. It will go this way. This is the field of view. Field of view. So it is the rays which are coming, it is getting actually diverging from the mirror. So it is called diverging mirror. See, the uses of concave mirror is, convex mirror is first, concave mirror, it is used for shaving purpose. One is for shaving purpose, for makeup mirror, as a makeup. Shaving mirror and makeup mirror, because it forms a magnified image when it is kept closer to the mirror. When it is kept closer to the that is between F and P, focal point and the focal point and the pole of the mirror, it gives a magnified and erect image. Already we have discussed that when an object is kept between focus and the pole, we get a erect image, and this is used for shaving purpose and makeup mirror. And since we get an erect image when it is kept closer to the face, that is closer to the face means when closer to the mirror. Then this convex mirror, this is a field view. So when we see through this area, this much area, we could see the image of the object. So in that case, so it is used as a rear view mirror in car, torch, And reflected rays have this reflected rays after reflection from the mirror. After reflection from the mirror, it will give a large field of view. So the car driver, when we see from the rear mirror, he get the lot of area for viewing purpose, so that he can drive the car safely. So these are the convex mirror means used mainly. There are so many uses of concave and convex mirror, but mainly these are the main point. This is used for the dentist to see exactly magnified image so that he can see it properly. For seeing the air, for seeing the throat, the concave mirror is used. Convex mirror is used for torchlight, where anything we want to focus it, for it to have a large viewing area, and as a rear view mirror in the automobiles.